What do seeds and states have in common? Well, the BI engineers at Microsoft had a meeting and they concluded that these names would work well together in the List.Accumulate function. But that's all they are, names that we can change. But before we get to that, let's first understand what List.Accumulate does. It's a list function that performs the same repetitive steps on a list, and once it's done repeating those steps, it then returns the accumulated value. For example, we have these lists of values here in Excel, and if we sum up these values, they equal to 200. So if we had to use List.Accumulate to do this in Power Query, that's the value it would return. Let's use this list of values to understand how List.Accumulate works. I've added the following column headers for the opening, current, and closing. And let's insert a row here and call this start. The purpose of the start row is to add an additional value at the beginning of our list. We don't want an additional value for now, so let's make this 0. Our current value will always be the same as the values in our list column. So let's make our current column equal to our list to sum column. And let's fill this down. Our closing will be the sum of our opening plus current. And let's fill this down. Now we just need our opening values, which will be the same as our previous closing. And let's fill this down. And we can see that the end value here is 200. If you want, you can add a 0 here. For consistency, it doesn't really matter. Now that we have our Excel explanation set up, let's dive into what makes up List.Accumulate. List.Accumulate is made up of 3 arguments. The first argument is a list. This is the list that you want to sum up. And the data type needs to be a list. So our list to sum column would be our first argument. The second argument is the seed. This is the first value that you want to be added in your sum. The data type can be any. In our Excel example here, seed is our start. So let's call seed start. This will help us keep track of what we're aiming for in each argument. The third argument is the accumulator function. And this argument is what makes List.Accumulate so powerful. Now let's dive into the accumulator function. A function in Power Query has 2 parts: the input and what needs to be done to that input. The input in the accumulator function has these 2 variables, state and current. In our Excel example, state is our opening, and we can keep current as that's the same as our example in Excel. So our values in our opening column and values in our current column are the inputs for our function. Now, as this is a function, our input will be followed by the arrow operator. The arrow operator is used to define functions in the M code. Everything after the arrow operator is what will be done to that function. As we want our values to be cumulative, we want this to be opening plus current. So this is the second part of our function. So we now have our list, start, and accumulator function that's made up of the opening, current, and opening plus current. Before we try this example in Power Query, we need to take note of the variable names that we've changed. Seed is now start, and state is now opening. Why can we do this? Well, think of state and current as your applied steps, and we can rename our applied steps as we prefer, and hopefully to what makes sense to us. I hope this makes sense to you. Please let me know in the comments. Now let's send this table to Power Query. Here in the Add Column tab, let's insert a custom column. Let's call this new column Cumulative Total. Now let's type our List.Accumulate function. The IntelliSense brings it up, so let's click on that and insert the open bracket. Our first argument is our list to sum. So let's select that on the right here and insert a comma. Our seed is our start, which we want to be 0, and insert a comma. Then our third argument is the accumulator function. So let's insert the open brackets, as functions are always in brackets, just like in Excel. Our first argument, which is the input to our accumulator function, will be opening, and insert a comma and type current and close brackets. then insert the arrow operator, as this will tell Power Query what we want to do to our inputs. And let's type opening plus current, then insert the close bracket and click OK. And we get this expression error. We cannot convert the value to type list. That's because our List.Accumulate function requires the first argument to be a list, whereas we gave it a column in a table and not a list. So how do we convert this column to a list? Let's click on the Change Type step here in the Applied Steps, then click on the FX in the formula bar and click Insert to insert a step. Power Query automatically references the last step, which is the Change Type. So here in the formula bar, let's type our column header in square brackets, which is list to sum, as columns are shown in square brackets, and press enter, and we have converted our column to a list. If you would like to understand more on how this M-code works and more on the advanced editor, please check out this video on the advanced editor. The link is in the description also. Now let's select this code and copy it and delete this step as we don't need it anymore. Let's go back into our custom column and paste the code here before the square brackets. Let's delete the second list to sum that we initially had. So we have our list to sum column, and we've now converted this to a list. We have our seed or start, and we have our function with our 2 inputs, and we have what we require to be done to those inputs. Let's click on OK, and we now get our cumulative total of 200, and it agrees to our value in Excel. But now let's say we want this to be a running total, like we have in Excel. We can either use list.range or list.firstN. In this example, we're going to use list.range. If you would like to learn how to use list.firstN in your running total, please check out this video here. The link is in the description also. Let's see how list.range works. Let's create a blank query, and here in the formula bar, let's type list.range, and the IntelliSense brings it up, so let's select that, and let's hit enter. So it says that it returns a subset of the list beginning at the offset list. An optional parameter offset sets the maximum number of items in the subset. So our first parameter needs to be a list. Offset needs to be a number, and count is optional, and it needs to be a nullable value, which means that count can be null. Let's put this into practice. Here in the formula bar, let's insert the open bracket, then the open curly bracket, as lists are in curly brackets, and let's type 1 to 10, and let's insert a comma after the closed curly bracket, and insert a 0, which is our offset. Our count is optional, so we won't add that for now, and let's hit enter, and we get our list from 1 to 10. And we can also see on the left here that our icon is a list and not a table. Let's change our offset to 2 and insert a comma after the 2, and let's add a count this time. Let's make it 4 and hit enter, and we get a list starting at 3 and ending at 6, which is a count of 4. So list.range helps us to return a subset of values, which is what we require. So if we go back to our table 1 query, only our sum total value of 200 is being returned, whereas we actually need this to be our running total, just like we have in Excel. First, let's determine which subset of values we need to return. We need to return our list to sum column. It cannot be this cumulative total column, as it would just return the same summed up value of 200. So that wouldn't work. Let's click on the gear icon of our added custom step, and here in our custom column dialog box, we need to figure out where in this formula we're going to insert our list.range function. A good starting point is to find the column that we want list.range to return, which is the list to sum column. We've already converted this to a list, as remember the first parameter in our list.range function is a list. So let's insert it here after list.accumulate. Let's insert an open bracket and type list.range, and the IntelliSense brings it up. Currently the IntelliSense is showing us the parameters for list.accumulate. So let's insert a space here, and it now changes to list.range, which means that we're now working on the parameters for list.range. Our first parameter needs to be a list, which it is. Then our second parameter is our offset. Let's make our offset 0, so that anything from 1 can be returned. Our count in list.range is optional, so let's not include that for now. Let's insert a close bracket, and let's not forget to insert the comma. Remember that the end of a parameter is shown by a comma, and if you're using more than one function, each function needs to start with open brackets and end with close brackets and a comma. Except for the end of a function, there is no comma, only a close bracket. So for our list.range function, we have our list and offset. Then for list.accumulate, we have our list, our seed or start, and we have our accumulator function made up of our opening and current inputs, and we're showing what needs to be done to those inputs. And let's click on OK. But we still get our total sum returned instead of a running total. Let's see what list.range is returning. Let's go back into our added custom column step and copy our list.range formula. So that's our list and offset. Next, click on the change type step, and in the add column tab, click on custom column and click on insert, and let's paste our code here and click on OK. So list.range is returning our entire list each time, but we do have help at hand, as list.range has a third optional parameter, which is count. What count will do is tell list.range how many values to return each time. So here in our first row, we want one value to be returned, which would be 20. And when we get to our second row, we want 2 rows to be returned, which would be 20 and 30, and so forth. Let's go back into our custom column step that only has our list.range formula. In the count parameter, we could add a number here, let's say 2, and click OK. And we now get a list that's only returning 2 values, and this is in each list. So this would not work. We need our count to be dynamic. So let's create a column that we can use as our count, and that will be dynamic. The best helper column for this will be index. Let's remove this custom column step as we don't need it anymore. And let's click our change type step, and in the add column tab, click on the drop down next to the index column and select from 1, and click on insert step, and we get this index column. Our index column will update automatically based on the number of rows in our list to sum column. So it's the perfect helper column here. So now how do we incorporate our index column into our list.range function? Let's open up our custom column step. The first thing to notice is that this changed from the change type step to the added index step. So Power Query updated that for us when we inserted the index column. So all we need to do is add the index column in our list.range function. So let's find our offset parameter, as the count comes after offset, and let's insert a comma and select the index column on the right here by double clicking it. No syntax errors have been detected, and let's click on OK. And we get our running total. So in our first row, list.range returned 1 value, as that's what our index column told Power Query in the count parameter of list.range. And list.accumulate summed it up, which is 20. Then in the second row, list.range returned 2 values according to the count indicated by the index column. And list.accumulate summed those 2 values up, which is 50, and so forth. So you can now see how list.range and list.accumulate work together to give us our running total. Let's put this into practice. This time, we want to use List.Accumulate to calculate the cumulative depreciation of these values. We have the year, the NBV or net book value, and the depreciation for each year. So let's use the principles we set before to guide us, which is this table here. Our List.Sum is our depreciation column, as we want the cumulative depreciation value as our end result. So let's make this column equal to our depreciation values and fill this down. Our second argument, which is the seed or start, would be 0. So let's add a 0 here in the opening column. And our third argument is the accumulator function, where the inputs are the opening and current columns. First, let's calculate the current column. Our current is the same as our list to sum. Our closing values are the opening plus current, and let's fill that down. And lastly, our opening is the same as our previous row's closing, and let's fill that down. And our closing row shows the accumulative depreciation. Now let's see how we can translate this into a powerful query using List.Accumulate. Remember, this was just a guide to show us how List.Accumulate works. So we're going to use our source data. I've converted this to a table, and we're going to send this to Power Query. For this query, we don't need the netbook value column, so let's remove that. As we need a running total, we need to insert an index column, as that will be used as the count parameter in our list.range function. So let's add column and index column from 1. Before we create our running total, let's remove the space here in our last applied step, which is the added index step. This will help us in our next step, and press enter. Next, let's go to Add Column tab and click on Custom Column. Let's name this custom column Cumulative Total. First, let's create our inner function, which is list.range, and insert an open bracket, as functions are in brackets, just like in Excel. Our first argument is a list, which we know will be the same argument that's used in our List.Accumulate function, which is the depreciation column. However, this needs to be a list, and all we need to do to convert this to a list is type our last step, which is added index. Then double-click on the depreciation column on the right here to insert it into our calculation, and we've now converted our column to a list. Let's insert a comma. Our offset will be 0, as we want our list to start at 1, and insert a comma. Our count will be our index column, so let's select that, and let's insert a close bracket, and click on OK so that we can see what list.range returns before we include List.Accumulate into our formula. And we get a subset of lists. So our first list returns our first depreciation value, and the second list returns our first and second depreciation values, as the count, which is indicated in the index column, was 2. And the third list has our first, second, and third depreciation values, as our count was 3, and so it goes. Now let's complete our calculation and go back into our added custom step. Now let's calculate our cumulative total. Let's type List.Accumulate at the beginning of our formula here, and let's insert an open bracket. Our first function is a list, which we saw List.Range returned as our subset of lists. So we don't need to do anything here. Let's insert a comma after the last bracket. Our seed or start will be 0. Insert a comma. And now we get to our accumulator function. As this is a function, we need to have our arguments in brackets. So let's insert our opening bracket. Our inputs will be opening, and insert a comma and type current, and insert a close bracket. Remember that the opening and current are the variables in which Power Query performs the calculations. So you can think of them as your applied steps. When you use an applied step, Power Query knows exactly what to do in that applied step, and we can rename steps. So it's the same here. Power Query knows exactly what to do in these two input parameters, and we can name it whatever we like. I'm using opening and current as that's what makes sense to me. So we cannot insert a column or a list or a value or anything else here, as this is just the placeholder where Power Query performs calculations. Then let's insert our arrow operator to show Power Query that this is a function, and let's type what we want to be done to our inputs, which is opening plus current, and insert a close bracket. So we have our list, we have our seed, and we have our accumulator function. No syntax errors have been detected, and let's click OK. And we get our running total, which agrees to what we have in Excel. Now let's say you wanted to find out the number of days of a certain day, let's say Monday in a specific month, let's say January 2023. And all you need to do is enter that day and hit invoke, and your query tells you exactly how many times that day occurs in that month. This will be a more complex example using List.Accumulate that I will show you in the next video, so please hit the notification bell so you know when that video is released. In the meanwhile, please check out this video here on the advanced editor. It's really going to help you up your Power Query game.